Hey all, this is Derek in section 6.4, Simplifying Roots. And so let's start off with the definition. So if x is a non-negative real number, then the expression square root x is called the positive square root of x, and is such that the square root of x squared is x. So what this is saying is if I have the square root of, say, the square root of 5 squared, the square and the root undo each other, and we just get 5. Another way of thinking about that is if I do the square first, that's like square root of 25. So square root of 25 is asking, which is more the word definition here, what number do I multiply by itself to get 25? And that would be 5. And the key here at the positive square root is on the idea of what number do I multiply by itself. Negative 5 times negative 5 also makes 25. So that's why we're being careful to define this as the positive square root is the one that we're looking for. I made a list here of the perfect squares just to reference them. You'll see a little bit later in the section that could be helpful. But for now, let me go on to some examples. And so the square root of 4 is asking, what do I multiply by itself to make 4? And that would be 2. Another way of thinking of a square root is a square root is quite literally the side of a square. So if I have a square that's area 4, what the square root is the length of each of those sides, or 2 times 2 makes area 4. This one is the negative of root 4, which just means it'll be the negative of square root 4 is still 2, so it's negative 2. And then for that negative 4 underneath, remember we're saying what times what would make negative 4? There isn't anything that times itself makes negative 4. And so this one is a DNE, and it turns out it can have what's called imaginary solutions, but that's something that we would look at next quarter, not in this course. This next one, root 17 times root 17, that kind of goes back to our definition there, which is that is root 17 squared, which is just 17. So anytime we see a root times itself, the roots are squared, it clears. This one is just a couple of simple square roots. So square root of 81 would be 9, because 9 times 9 is 81. Square root of 4 makes 2, and now I can simplify. And 9 minus 2 would make 7, and that one I meant to delete, so ignore that. Okay, for these next ones, we are still simplifying, so we're just going to go 2 plus, and then what times what makes 64, so that would be 8 over 5, and now I can simplify this, so 2 plus 8 would be 10 over 5, or 2. For this one, we'll leave that 21 alone for a second, minus 5. Square root of 9, that's going to make a times 3 right there, over 3. Careful not to cancel those 3's. You could cancel both places, but probably better to just do this instead. Make that a 15 over 3. And then 21 minus 15, we'll finish putting together our numerator, and that will make 6 over 3, or 2. These next couple are just kind of getting you introduced to your calculator. So this is give a decimal approximation round to the thousandth. So this is what's called an exact solution. When we have that radical notation going on, that is the exact value. We're saying whatever number that we multiply by itself to make 2, that's what this root 2 is representing. And that number is like 1.41, but it goes on forever. It's irrational, like pi, it never repeats. So this is the exact form. Anytime we show it as a decimal, that's our approximation. So to put these in the calculator, it will really depend on your calculator, but this is basically just saying 6 times, on this one it happens to be a root button right there, and 2, and then close out your parenthesis, and they're rounding to the thousandths, so we'll go to 3 places, so that would be 8.485. And then this one, we're going negative 5, so for this calculator that would be here, negative 5 minus 3, and then times root 7, and close parenthesis. As that is negative 12.937 to 3 places.